So for what we are seeing over at Abina, we are seeing about an static characteristic of a measurement system. So today we are going to see about what about the dynamic characteristic of transmission. Actually, it relates to the performance, and the measured quantity is a function of time. Whereas it varies rapidly with respect to time overflow. So while the static characteristics relate to the performance of the transducer, and the measured quantity is essentially constant, the dynamic characteristics relate to dynamic input, which means that they are dependent on its own parameters as well as the nature of the input signal overall. Okay. So when we are seeing over here, actually we'll be having about an dynamic error, fidelity, speed of response, and the bandwidth. Okay. So these are all about the dynamic characteristics. So whereas here the speed of response and the fidelity are to be the desirable characteristics, whereas the bandwidth and the dynamic are to be the undesirable characteristics. Okay. So overall, both static and dynamic characteristics determine its performance and indicate how effectively it can accept the input signals and reject the unwanted inputs overall. Okay. So when we are defining a speed of response, actually it is defined as the rapidly in which the measurement system responds to changes over here. The next one we have to see about an bandwidth. So actually it refers to the delay in the response of a system to changes in the measured quantity. And the third one to be the fidelity. So it is defined as the degree to which a measurement system indicates changes in the measured quantity without any dynamic error. And the last one, we are in need to calculate the dynamic error. Actually, it is also called as measurement error. It is the difference between the given value of the quantity changing with time and the value indicated by the measurement system if no static error is assumed. Okay. So the maximum amount by which the pointer moves beyond the steady state is called overshoot overrunner. So these are all about the static characteristics of an measurement system. Okay. The next thing we are in need to know, what about the characteristics of sensors? So a good sensor should have the following characteristics. The first one to be the high sensitivity, and second one to be the linearity, third one to be the high resolution, fourth one to be the less noise and disturbance, and last one to be the less power consumption. So what is sensors? We know that it is a device which receives stimulus and response with an electrical signal. Okay. So there is the which is sensed and converted into an electrical signal. So what about its characteristics? The high sensitivity. What is sensitivity indicates how much the output changes with respect to an input. Okay. And what about linearity? So the output should change linearity with the input. That is, we should have a direct proportion in the case of an output to the input. And what about resolution? So we know that resolution is the smallest change in the input that the device can detect. And when we are saying about an, we'll have a less noise and disturbance, and we'll be having of around less power consumption. The next we have to see about an, what about the performance measures of sensors? Actually, already we are seeing about it. We will be recollecting what about the performance. So we will be classifying of two different characteristics. One to be the static and other one to be the dynamic characteristic. Okay. So when we are defining the static characteristic, the first one to be the transfer function. So what about transfer function? Actually, there is the theoretical output which exists for every sensor. So the sensor is ideally designed and fabricated with the materials by the workers using some tools. The output would represent the true value of the stimulus. Okay. So the ideal output stimulus relationship is characterized by the transfer function. So what is this function established? It depends between the electrical signal produced by the sensor and the stimulus. So for example, the output will be given the function of an input over here. The function may be a simple linear connection or non-linear dependence. This will be for a transfer function. What about span? So we know that it is defined as a full-scale input. There is a dynamic range of stimuli which may be converted by a sensor is called a span, or it can be named as an input to scale. So it represents the highest possible input value that can be applied to the sensor without causing an unacceptability large inaccuracy. So for the sensor with a broad and non-linear phase characteristic, a dynamic range which is expressed in decibels, whereas the logarithmic measure of ratios of either of power or force. Okay. So when we are saying about here, and it's over. The next one to be the full scale output. Whereas in the case of a full scale output, it is the algebraic difference between the electrical output signals measured with maximum input stimulus and the lowest input stimulus applied over here. Actually, this include all deviations from the ideal transfer function. And the next one to be the accuracy. So we know that the important characteristic of the sensor is to be the accuracy. The highest deviation of a value represented by a sensor from the true value at its input overall. And what about the calibration? The calibration if the sensors manufacturer tolerances and the tolerances of the interface circuit are broader than the